Hello, today we're going to talk about the types of chemical bonds. So there are three main types of bonds, and we're going to talk about how to classify them first. There's ionic, covalent, and metallic bonding. And ionic compounds exist when a bond forms between a metal and at least one nonmetal. Now let's review really quick on the periodic table. My generic periodic table. Remember, there's a staircase line that goes roughly here. Not exact, but everything to the left of that line are metals, and everything to the right of that line are nonmetals. So if you have one from each section, it's going to be an ionic compound. Now, ionic compounds, we're going to talk about this in more detail, but they form when there is a transfer of electrons. So one atom will gain and one atom will lose the electron. In covalent bonding, you only have nonmetals present. Only nonmetals. So that means you only have ones from the right side of the periodic table. A good example would be something like a CO2, because carbon and oxygen are both nonmetals. Covalent bonds form when there is a sharing of electrons. And we'll talk about that more in depth in a later section. Metallic substances, on the other hand, consist of only metals, which means that you're going to have only elements from that left side of the periodic table, which is the most of the elements, only metals. And they have where the valence electrons are free to move. Valence electrons, and again, we will talk about this in more depth in a later section. But the valence electrons are free to move throughout the compound. So if you have a pure metal, like if you have a piece of copper wire, that's a metallic substance. Or if you have a sample of brass, that is an alloy. And brass consists of copper and zinc together. That would be metallic bonding. Let's take a second and talk about hydrogen, because hydrogen is kind of weird. So it is in group 1 on the periodic table, so it's in that section with the alkali metals, but it's not really a metal. It can act as a metal sometimes and sometimes not. So I'm going to write it this way. It can act as either a metal or a nonmetal, depending on the specific situation, the specific compound. And there's a clue for how this works. So if I see hydrogen in the front, like if I have, let's say I have HCl, hydrogen is in the front, that is a clue that it's acting as a metal. But if you have hydrogen later in the compound, where it's not the first element, then it is acting as a nonmetal. Now this isn't perfect, but it's a nice clue to help us figure it out. And it's enough depth really for the honors level chemistry class. So this would be a metal with a nonmetal. It's an ionic bond forming. Whereas in the CH4 compound, carbon is a nonmetal. Hydrogen is acting as a nonmetal. Both nonmetals, it would be covalent. So this would be ionic covalent. So be careful with hydrogen. Now you need to have this idea of how they're going to separate when they are melting or dissolving. Ionic compounds break into ions. They break down into separate ions. So let's look at an example. I'll use sodium chloride. Sodium is a metal, chlorine is a nonmetal ionic compound. When it melts or when it dissolves in water, it's going to split apart into sodium ions and chlorine ions. That. So they break down into separate ions. Covalent compounds typically are in molecules, and for the depth of this class, molecules is enough. So when you have a bunch of water molecules together, for example, water is H2O, and water molecules are covalent, have covalent bonds. These are covalent bonds because they're all only nonmetals. They form these weak interactions between water molecules. And when water melts or boils, only those weak interactions, which are called intermolecular forces, only those break. You're not going to see breaking of the covalent bonds when it's melting or dissolving in something. Now, metallic substances consist of metal ions and valence electrons. So you'll have like the positively charged metal ions and the electrons wind up around the outside. So when it melts, those things kind of separate, but they don't fully, because a liquid is not completely 100% separated like a gas. If it was a gas, then the electron would have to go back with its metal ion. So those are the things that it would kind of separate down into if it was melting or dissolving. Now let's talk a little bit more specifically with covalent bonds. Remember that covalent bonds form between only nonmetals, and they involve sharing electrons. So when you have a polar bond, they share the electrons unevenly. Versus a nonpolar bond, they do share the electrons evenly. So a good way to check is to look at the different types of elements involved. If you have two of the same element, like if you have oxygen gas, oxygen is going to form a bond, well, it's really a double bond between the two oxygen atoms. But since they are both oxygen, same type of atom, they're going to share the electrons evenly. It's like they're evenly matched in a tug of war. A polar bond, on the other hand, would be something like the hydrogen-oxygen bond in water. The hydrogen and oxygen are pulling on the electrons shared in this bond unevenly. They don't have the same pull. And so because of that, they form a polar bond. Now, at this point, it's important to know just a couple of properties about these types of compounds. So we've got ionic, polar covalent, nonpolar covalent, and metallic. The first thing I want to talk about is solubility in water. So can it dissolve in water? That's what solubility is referring to. Ionic compounds are soluble in water. They can dissolve in water because the positive and negative ions can interact with the water molecules. Polar covalent can also dissolve in water because their oppositely charged ends can interact with a water molecule. Non-polar covalent compounds cannot dissolve in water, and metallic substances can also not dissolve in water. Another thing would be conductivity. And let's check, typically when we're performing these tests, you can check conductivity, like does it conduct electricity? And we're going to check as both a solid, let me change my label here. We're going to check as both a solid or dissolved. And we'll say conducts electricity. And that's a little better. So the only compound that can conduct electricity when it's still a solid is a metallic substance because the electrons are free to move. So ionic compounds cannot conduct as a solid, polar covalent cannot, and nonpolar covalent cannot. None of those can conduct electricity when still in the solid form. But once it's dissolved or melted, then ionic compounds can dissolve, or can conduct electricity, excuse me. But polar covalent and nonpolar covalent still can not. Metallic was going to depend more on the situation. Like if you melt a metal, it typically can still conduct electricity. So that should be enough to be able to distinguish between the four types of solids. So testing whether or not it dissolves in water, testing whether or not it conducts electricity as a solid, and testing whether or not it conducts electricity when they are dissolved or melted. And we can determine from that which one is which.